This video is to describe how you ought to write your methods for your SDH paper. So here's the thing. The SDH reactions that you did, and you see them here, right, they worked because there was the correct relative amount of buffer and enzyme and substrate. We did them in a total volume of 3 ml, right, and it's going to show you that here. 3 ml, there we go, 3 ml. We did them a total volume of 3 ml, and you could, all the way across, it keeps equaling 3 ml, right? Because that's the volume that fits in the cuvettes, that fits in the spectrophotometers that we have in Bio 11, right? If the interaction that we did is true, and of course it is true, then the exact same result would occur if the reaction total was 1 ml or 10 microliters or 35 liters. It wouldn't matter. When we write the lab manual, we want to show students in Bio 11 at Hofstra University how to do a reaction with the reagents and the tools that we have. But when you write methods for this manuscript, and really that's what your lab report is, it's a scientific manuscript. You write it so the focus is not on exactly how the reaction fit in your cuvettes, but on the relationship between the molecules. Now, I showed you in lab how we used the M1V1 equals M2V2 reaction to show the final concentration of succinate in the reaction was 10 millimolar, right? The important thing about the concentration of succinate in this reaction was that the final concentration, that is 500 microliters of 60 millimolar succinate in a 3 ml reaction, right? That's 10 millimolar. That's the important thing. Now, as it happens, we had 60 millimolar stock in lab, right? But just about any concentration of succinate could be used, 100 millimolar or 230 millimolar or 2 molar. You know, obviously you wouldn't use too much if you had 2 molar, but whatever you had, it wouldn't matter as long as you used the right volume of stock so that the final concentration, once it was diluted in whatever total final volume you had, would be 10 millimolar. Okay. Now, we have some over in Blackboard, right? Here in Blackboard, in, let's see, on course documents, right? It's up at the top, or you might have to scroll down a little bit depending on what section you're in. We've got some examples of papers that are good examples of how methods are written for reactions like this. Let me click on this, and yes, this one is perfect. Right? So here's the paper. You can scroll to the top. Here's the title of the paper, but down here on the 3rd page, right? In vitro metabolism enzyme assay. Right. Let's look at these methods. Liver tissues were homogenized 1 to 10 weight volume in 10 millimolar heaps, 3 millimolar beta-mercaptoethanol. Right there. This is actually how you could write you could write methods for how the homogenate was made to begin with, the original homogenate. Remember that 1 gram in 20 mils? Well, that's what this means. 1 to 10 weight volume, 1 gram in 10 ml. So they made their homogenates a little bit differently, a little more concentrated than we made ours. Right? And they made it in 10 millimolar heaps, and heaps is just a buffer. It's not herpes, it's heaps. It's, like I said, it's just initials that stand for some buffer. It's a little more complicated than sodium phosphate, but in principle it's the same. Right? Blah, blah, blah. Okay, the supernatant fractions were kept at -80. Oh, doesn't that sound familiar? Until analyzed for activity. All right. Okay, down here, malic enzyme activity was determined by a modification of the method of Shu and Lardy. All right, we don't have a reference like that. Okay, reactions included 50 millimolar heaps, pH 7.5, 1 millimolar NADP, 10 millimolar magnesium chloride, and the substrate, 2.2 millimolar L-malate as the disodium salt. in a total volume of 1 ml. Portions, 50 microliters, of the 12,000 G supernatant. Now, we didn't look at this, but this is, once they made their homogenate, they spun them first and they kept the top part. That's the supernatant. So, in other words, you can just fill in homogenate for 12,000 G supernatant. Right. Portions of the 12,000 G supernatant, now, they diluted theirs 1 to 10 first. We didn't do that. We used our homogenate straight. So portions of 50 microliter portions were pre-incubated in the presence of the first 3 ingredients. Reactions were initiated by adding the substrate and following the rate of reduction per minute of NADPH at 340 nanometers. Right. So we could have written ours, right? This is really very analogous to how we did our reactions. The way we did ours is we added everything but the homogenate, and we initiated the reaction by adding the homogenate. They added everything but the substrate, and then they added the substrate and they let it go. The reason we didn't do that was because of the whole background thing and the control in reaction 1. We needed to correct for that. Right? We had a reason for doing it the way we did it. So, do you see how brief this is? Now, the only thing that's not, actually they say they're following the rate of the reaction, so they actually did the reaction in a spectrophotometer, obviously, because they're following per minute, so they're measuring NADPH formation in the spectrophotometer, which is set up, their spectrophotometer is actually 30 degrees. So they have a little more complicated situation than we did. We took an initial and then a final, and we did the subtraction, and then we did the math. So they didn't do any other math like we did that you would have to include here. But otherwise, notice how brief this is. There's not a humongous table including everything that they added. And so indeed, this is my next thing, right? You will not include this table, right, in your methods. You will write a paragraph, and you're going to start with the things that all the reactions had in common. So what was that? Well, the first thing was the sodium phosphate buffer. Right? Every reaction had exactly the same concentration of sodium phosphate buffer. And the reason the concentration is always the same, even though the volumes are different, is because every single reagent was made up in 50 millimolar sodium phosphate buffer. So instead of dissolving my DCIP in water, I was dissolving it in sodium phosphate buffer. And since everything is in sodium phosphate buffer, the final concentration is 50 millimolar. You do not have to do any math to figure out the final concentration of sodium phosphate buffer. It is 50 millimolar. So that's common to all reactions. The other thing that's common to all of the reactions is DCIP. Now, what's the final concentration? I'm going to leave that to you to calculate, right? So use your M1V1 equals M2V2 equation to figure out the final concentration of DCIP, right? So every single reaction had exactly the same final concentration of sodium phosphate and DCIP. They had the same every reaction, but what was next? The blank, right, had the tissue homogenate, and they all had the same volume. And again, this is the only place where volume matters. You do need to mention the relative amount of homogenate per volume of reaction. So whether you do it 250 microliters in a 3 ml reaction, or you do a ratio, a percent, right? It's this percent, right? It's whatever it is. I'll let you do that math too, right? And then, is that it? No, then the other things you want to mention are the succinate and the malonate. Now, they didn't go in every single reaction. When succinate was present, it was always present at 10 millimolar, right? We already know that, right? I told you that in the lab manual. It was absent from one of the reactions. So you have to tell your reader that the succinate was present at 10 millimolar except in blankety blank reaction. And instead of writing blankety blank, you tell the purpose of that reaction, right? And then malonate was present in increasing volumes, increasing volumes, but increasing concentration. Now, the reader is going to read in your lab report exactly what those concentrations are. So you can simply give the range of concentrations that was tested. Right? Now, I hope that's clear. Please refer back to these papers for guidance, but remember, keep it short, keep it concise, and do not put this table in your methods. Okie doke.